Well, you've made it. Congratulations. Here we are at the last section, section 6 for chapter 18. We're going to be talking about bacterial diseases and antibiotics, what they are, how we treat them, so on and so forth. Goals for the section, as always, know all of the vocab, know how bacteria cause diseases, but also know about how many of them cause disease. Is it many? Is it most? Is it few? And the role and use of antibiotics. How are they good? How are they bad? How have they been misused lately? Okay, so the important part to understand about bacteria is that by and large, they are very good. We need them. We learned last section about how important they were to bioremediation and how they decompose, how they make food for us. If we didn't have bacteria, we didn't have any of those things. That would be very bad. So it's good that they do all that, but there are some drawbacks, right? The fact of the matter is that some bacteria can cause some pretty nasty infections, right? And they do that by releasing these things called toxins, right? So what are toxins? Toxins are just poisons released by an organism, right? So they inhabit our body, they release toxins, and that is not good for us. One example of that would be tuberculosis, right? That's really nasty. You get it in your lungs, and they kind of inhabit your lungs, and even though your body tries to fight them off, the toxins kill your immune cells, and it causes your lungs to swell and bleed, and you cough up blood, and you're probably going to die, right? It's a pretty nasty disease. Edgar Allan Poe wrote a lot about tuberculosis. It's not so much a problem anymore, but it's still a danger if you get it. Not many people get it anymore, but it's still pretty dangerous. What is that caused by? The bacteria. Now, it's also important to understand that where and when a bacteria inhabits something is just as important as if it's dangerous or not, right? Some bacteria are perfectly fine in one part of your body, but will wreak havoc in another. One example of that would be Staphylococcus aureus, right? Or it's just staph for short. So staph is normally found in our nose and our nostrils, and it's perfectly fine. That's not going to do any harm to us. But sometimes when people touch their nose and then touch their eye or their mouth, right, the bacteria go from the nose into the mouth, into the eyes, and go places where they're not supposed to go. And if a staph bacteria gets into your stomach or your intestines, well, you can get food poisoning from that because they start releasing toxins that are something your body does not want inside of it. And I think we all know how unpleasant that is, so I'll just leave it at that. Another way staph can be pretty bad is if it gets deeper than just skin layer, right? So staph lives on our skin. It's totally fine. It's not going to do anything. We know how good of a barrier that the skin is, but if there was an opening in the skin, like a cut or a wound of some kind, and staph get in there, you can get a very serious infection called a staph infection, or even worse, the antibiotic-resistant MRSA infection. Right? That's just staph that has a resistance to a couple of antibiotics that are commonly used. Right? It will break down those tissues like it breaks down the bad stuff from before, right? Because bacteria, they don't think, they don't know. They're just looking like, oh, look at that, fat. Ooh, look at that, muscle, when they just digest it. Not because they're trying to harm you, but that's just what they're biologically driven to do. So where and when an organism is, bacteria specifically, is just as important as if it's damaging or not. One bacteria can be totally safe and fine in one area of your body, but can be very destructive in another area of your body. Now that brings up the antibiotic. So antibiotics are good things, really they are, right? And you can tell just from the name antibiotics, they're anti-living things, which sounds kind of bad when you think about it, but antibiotics work on killing bacteria, not viruses though, right? Why is that? Well, there's a good reason. Antibiotics either prevent or break down the formation of a cell wall. And viruses, do they have a cell wall? No, they don't. So antibiotics can't work on them because there's nothing for the antibiotic to attack on a virus. In the same way, animal cells, do those have cell walls? I don't remember. Maybe if you find one, you let me know, but For all we know, no animal cells have any cell walls, so animal can be subjected to antibiotics without any ill effects because there's nothing in an animal for an antibiotic to attack. So they're really neat, really revolutionary. They have saved lots of people's lives. Now, that's a good thing. Of course, it's a good thing, but there is an appropriate way to use them and an inappropriate way to use them, just like anything else. And it became a problem when they were being misused. The misuse of antibiotics causes something called antibiotic resistance. And that's exactly what it sounds like when a bacteria becomes resistant to a specific kind of antibiotic. That is not a good thing because if you're in a dire situation and a bacteria has infected you and might be killing you, you want that antibiotic to work. You need that antibiotic to work, right? When we misuse antibiotics in a few different ways, we'll talk about shortly, it gives them a better chance of surviving, right? The first way is through overuse. So remember how powerful our immune system is. It's like the search and destroy automatic thing that will go and kill anything that's not us. If you go to the doctor too much and you use antibiotics too much, that's called overuse. Now, antibiotics, well, let me ask you, do you think that they can tell a difference between one bacteria and another? They can't, right? Cell wall is a cell wall is a cell wall to an antibiotic. It's just meant to break down or prevent that from forming. And remember, most bacteria are good or neutral. So if you're just killing, like you're just nuking a bunch of bacteria, that's not a good thing. You need those bacteria. What can happen is you end up killing the good bacteria, and that makes a space for the bad bacteria to inhabit where formerly they weren't before. Okay, that's called a opportunistic pathogen, right? When there is a opening that formerly wouldn't be fulfilled by a bacteria, but when it does, it becomes a bad thing. Now, another way overuse is bad because it can cause a lot of resistance. So if you keep subjecting bacteria to the same antibiotic over and over and over again, what it's going to do is strengthen the overall community of bacteria, if that makes sense. There's a pretty good chance that one of them has some kind of mutation that enables resistance. And while the antibiotic kills all the ones that are already weak to it, it leaves the one that's pretty strong, right? And then that one's free to replicate and become the new normal bacteria. The same thing can happen with underuse, right? If you ever have been sick and needed a antibiotic, you would have seen you're supposed to take it like every 12 hours, every 6 hours, every 8 hours. And it's really important to do that, to have that continuous dose of antibiotic doing its thing, doing each one by the hour or doing it daily and missing one or two. It's not good because it gives the bacteria a chance to recuperate. Not good. So you kill off the weaker ones and then the stronger ones come back. You need to be subjected to the antibiotic for the entire course to make sure you get all of them, or you might leave some of the stronger ones alive to repopulate. Now, misuse is another way, and one big misuse is using antibiotics on animals to kind of prevent them from getting sick in the first place, but it had the opposite effect. So if you overuse, misuse, or underuse the antibiotics, all that does is cause more bacterial and stronger bacterial infections. So again, it's not that antibiotics are bad, they're good, especially if you need them, but using them improperly is what is bad. Like anything else, you can't do something in a wrong way and expect the outcome to be good. So here's an example of what happens with bacterial resistance, right? So you got a big old population of bacteria, and the purple ones are normal, but this pink one has some kind of resistance to it. You use antibiotic, it kills all of them except for the pink one here, and then it replicates itself, and then soon it's only the one that's every single bacteria has this resistance. So that's what it looks like. All right, so in review, what substances can bacteria release that are harmful? Are all bacteria harmful? What is used to fight off bacterial infections in addition to our immune system? that needs to be used appropriately, or bad things will happen, and what bad things will happen if we do abuse those things. All right. Thanks for watching. If you have any questions, make sure to email me. I'll respond to you as soon as I can. Get ready for your quiz. Get ready for your test. Make sure you turn in your homework. Talk to you guys later. Bye-bye.